Alright, so now we are going to solve systems of inequality. So this is all about graphing, so make sure you are ready to graph, and if you're taking notes on regular paper, you have some graph paper ready, and you are ready to follow along and take excellent notes. Alright, so here's an example of a system of inequality. So as you see, I have two different lines here, and both are inequalities. So what you do first is you graph one line. So here, this is the first line. Alright, and notice it's less than or equal to, so I shaded below, and the line is going to be solid. And the second line here is greater than or equal to, so it's shaded above. Again, the line is solid. And then here is the system together. So all we did was we graphed the two lines on the same coordinate plane. Now our solution is going to be wherever they overlap. So that's going to be this part of the graph. Okay? So this is going to be my solution set everywhere where they overlap. Alright, so here is where all of the coordinates will work for both inequality. So when we're solving a system of inequalities, that's what we're looking for. We're looking for the coordinates that will satisfy both inequalities. Okay, so that's just like our regular ones, except for now, instead of just a one point, it's going to be a whole section of the coordinate plane. Alright, so we are going to graph the system of inequalities. So first I'm going to write the top guy in slope-intercept form. So it's going to be y is less than negative x plus 5. I'm going to go ahead and graph that one first. Okay, so the y-intercept is 5, so I'm going to go up to 5. 1, 2, 3, 4, 5. Slope is negative 1, so down 1, right 1, down 1, right 1. I didn't even say that right. Down 1, right 1. Say that 5 times fast. Okay, up 1, left 1. Okay, and then I'm going to connect my dots. Now, this was, if I would have looked ahead of time, this is a less than inequality, so it's going to be dotted or dashed, whatever you like to say. Okay, so that needs to be dashed. And I'm going to shade below. Okay, so I'm going to shade all of this. Alright, so that I'm going to go ahead and label some points. That's my y-intercept 0, 5. Okay. So graphing the next one, I'm going to use a different color. Obviously, you don't have to. So y is less than 3x minus 2. So I'm going to go down to negative 2. That is going to be my y-intercept. Okay. Slope of 3, so up 3, 1, 2, 3 over 1. Up 3 over 1. Up 3 over 1. Down 3, left 1, down 3, left 1. Okay, and again, that's a dashed line, so this time I'm going to pay attention and just draw a dashed line the first time. Alright, and that is less than. So remember, we want to shade towards the negative values of y. So that's this way, okay? This is where y is getting smaller, so I want to shade that way. Okay, now where those two crossings overlap, this area right here is going to be my solution. So I'm just going to emphasize that. This is my solution set. Okay, all the points in this quadrant, all the points here will work for both inequalities. Okay, so let me just label some points here. Okay, this is where labeling your line comes in handy. Alright, so this is where if you label your line, it's easier for me to tell what is what. Alright, and there we go. Alright, so a gardener wants to plant at least 50 tulips and roses in its garden. Okay, so at least 50 tulips and roses means that combined together we need, at the bare minimum, 50 tulips and roses together. Alright, Now, we want no more than 20 rose plants. So we want more tulips than roses, and we cannot have any more than 20 rose plants. So I'm going to let T be tulips, and I'm going to let R be roses. All right, now I need to write a system of equations to model this. Now, tulips plus rose plants has to be at least 50. Now, at least, again, remember, means I could have more, right? But the bare minimum is 50, so that's going to be greater than or equal to. But no more than 20 rose plants. So rose plants has to be less than or equal to 20. Now, normally when we do things like this, we do alpha order. So R comes before T. So I'm going to let R be our rose, our X. So roses will go on the x-axis. And I'm going to go up by 5s here. That's a 6, not a 10. Okay, and then you keep going from there. And then tulips is going to be on the other side. Again, we're going to go up by 5s. Okay, so since R is already solved for right here, and we're treating that like X, then X is less than or equal to 20 is going to be a vertical line at 20. Less than or equal to is going to go this way. Okay. Now the next one, I actually have to solve for T here. So I'm treating T like I would Y. So I'm going to bring the R over. So this is like saying Y greater than or equal to negative X plus 50. So 50 is my y-intercept here. Now negative 1 slope, I want you to realize that since my units is going up by 5, going down 5 and right 5 is the same as doing a negative 1 slope. Okay? So down 5, right 5, can continue on. All right, and then I'm going to connect my dots. Now we have greater than or equal to, so we're going to shade above. So your solution is going to be this overlapped region over here. Okay. Now what does that mean? That means, let's say we had 15 roses, then all the different combination of tulips that I can have are right here. So if I have 15 roses, then I can have anything from 35 to 50 roses. Okay, I'm sorry, tulips. So if I have 15 roses, I can have 35 to 50 tulips. Now, let's say I have 10 roses, then I have to have at least 40 or 50 or more. Okay, so at least 40 and then 50 or more. So make sure that you realize this is all the different combinations of possibilities of tulips and roses I can have. All right, so here we have another absolute value with a line. So let's go ahead and graph the line. The y-intercept is 0, 0. And my slope is negative 4/3. So I'm going to go down 4 over 3. Down 4 over 3. Up 4 over 3. Okay, and that's going to be a solid line. Oops. All right. So now I'm going to go ahead and graph the other line after I label my y-intercept. All right, so the other line is going to be an absolute value, so it's going to be a V with a vertex at 0, 0, and it's going to be facing downward. Okay, now my red line is also solid. And for the absolute value, we want to shade everything greater than. So I'm going to shade everything greater than. Okay, and then for the line, it's everything less than. So I'm going to shade towards, remember, the negative values of y here. Okay, so the overlapped region is going to be this region right here. Okay, everything inside of here is going to be a solution. All right, all those points will work on both of the inequalities. Give these U-try problems a shot.